Okay, 6.2, similar polygons. Students will be able to identify similar polygons and solve problems involving scale factors. This is why we needed to learn the ratios that we learned last time. Okay. When polygons have the same shape, but may have different sizes. And polygons, by the way, just means something with multiple sides. I'll get more into that later, but for example, this is a polygon, and this is a polygon, because it has multiple sides. But may have a different size. They are called similar polygons. My handwriting is atrocious. So this means that all their corresponding angles are congruent, and the measures of their corresponding sides are proportional. So this little symbol here is similar to, and we could say, hey, look, angle D here is congruent with angle H, angle C is congruent with G, F is congruent with B, and E is congruent with A. That's what this means. And notice I put them in corresponding order. Okay, so that's what similar means. It also means that their corresponding sides are proportional. So we should be able to say that, for example, DC over HG would be equal to any other side. So we could pick any other side. We could say BC should be equal to BC from the bigger polygon to this side over here that corresponds with our original polygon, which is GF. And we could say that's true if we picked any side. So DA over HE should be equal to AB over EF, and all of these guys as well. So we'll put that into practice here. Let's take a look at this triangle. Well, a triangle has three sides, so we're going to have three sides that we compare proportions with. So let me zoom in on this guy. We're going to determine whether each pair of triangles are proportional or not, or if they're similar. Well, let's first find out what we know. Look, I have a 30 here and a 30 here. That means that this angle here is going to be congruent with this angle here because I have a 90, 90, 30, 30, and then I'd have a 60 and a 60. Now, it's important to recognize that this triangle is kind of flipped upside down, right? EFD is upside down compared to ABC here. But we can still tell what corresponds with what, right? So A looks like it corresponds with D, B corresponds with E, and C corresponds with F. So we could figure out what side should correspond. We know that AB should correspond to ED, BC to EF, and AC to FD. Well, let's see if that's the case. Let's see if they're all proportional. So let's take AB and let's put it over ED. Let's take BC and let's put it over EF. And let's take AC and let's put it over FD. Okay, well, AB is 12 and ED is 9. When you reduce that, you get 4/3. Okay, BC is 6 and EF is 4.5. When you reduce that, you get 4/3. So far, I'm seeing a pattern. Let's check the last one. AC is 6 rad 3 over 4.5 rad 3. Well, that ratio is obviously the same as this one here because rad 3's just cancel out, and you're left with 6 over 4 rad 5. 6 over 4 rad 5. So that must be 4 over 3 as well. Since they are equal, we can say, yes, that these are in fact similar. Yes, they are. Check mark. Yes, they're similar. Let's compare the next one. Okay, so we got two rectangles. And obviously, the longer side on both of these is going left to right, because this is 6 compared to 5, and this is 7 compared to 6. All the angles are congruent, so let's see if the sides are proportional. Well, this one is 7 over 6, and this one is 6 over 5. Well, do these equal each other, right? No, they don't. We could test this a few ways. I mean, you could put 6 over 5 in your calculator, see what you get back, and put 7 over 6 in your calculator, but you'd get two different numbers. So I'm going to do that real quick. Get my calculator out. So 7 divided by 6, that's actually equal to 1.16 repeating. And 6 divided by 5, that's equal to 1.2. So sure enough, these are not equal. They're close, but they're not equal. So these rectangles are not similar. Not similar. So that's really all it takes to figure out if something is similar. All the corresponding angles should be congruent, and all the sides should be proportional to the exact same proportion. When you do a ratio of this hypotenuse to this hypotenuse and compare it to this side, the ratio should be equal. They should be proportional. That's the word we learned last lesson. Okay, let's take a look at this guy. Given the two polygons are similar, so find x, y, and ut. Well, if they are similar, then there's going to be some common ratio between them. Well, they give us this side st and this side bc. They're obviously corresponding because b and s correspond and t and c correspond. So what's the ratio of 18 to 4? Well, let's just write it. 18 to 4, that would reduce down to 9 to 2. So if they're similar, which it says that they're all going to have this common ratio. So, for example, when we want to solve for x compared to 3, we could say, hey, x over 3 has to be equal to 9/2. So let's do it. And now we can do the cross product like we did before. And 9 times 3 is 27, and 2x. Divide by 2, divide by 2, and we get x equals 13.5. Alright, we found x. Now let's talk about y. Well, y plus 2 is tu, which corresponds to this side length of 5. So let's use our ratio again. We would say, I'm going to zoom in a little bit. We would say, hey, 9 over 2 has to equal y plus 2 over 5. Take the cross product. I get 2 times y plus 2 equals 9 times 5, which is 45. Distribute that 2. Subtract 4. Subtract 4. 2y equals 41. Divide by 2, and I get y equals 20.5. And lastly, they wanted to know what this distance ut was. Well, it's equal to y plus 2. So I can just say 20.5 plus 2 is equal to ut. So ut equals 22.5. No problem. Okay. So there's the first thing in notes. Let's go on to the next page.